Hello, everyone, and welcome back to our YouTube-style science podcast. I'm Alex, and today we've got something incredibly exciting for you. We're talking about hail. Yes, hail, the surprising, powerful ice that falls from the sky. You might think you already know what hail is, but trust me, after today, you'll see it in a completely different way.
Hi, friends. I'm Mia, and I'm so happy you're here with us. When we picked the topic of hail, we thought, oh, this will be simple. But once we started researching, we realized hail is way crazier, more dangerous, more beautiful, and more scientifically fascinating than we ever imagined. So get ready because we're breaking down everything about hail, from how it forms to why some hailstones are the size of softballs.
Let's start with the basics. Most people think hail is like frozen rain, but that's not fully true. Rain freezes when the air is cold, sure, but hail forms in warm seasons too. Hail begins its life inside a thunderstorm, high up in a tall, powerful cloud called a cumulonimbus cloud. These clouds can rise over 50,000 feet into the sky.
Yes, and inside those clouds are incredibly strong updrafts, columns of fast-rising warm air. Imagine standing in front of a giant hairdryer on full blast. That's sort of what an updraft is like, except way stronger. These updrafts can be so powerful that they push raindrops upward back into the freezing cold part of the cloud.
Right, and here's where the magic begins. When that raindrop gets pushed upward, it freezes into a tiny pellet of ice. Now that pellet starts falling down again, until the updraft grabs it a second time and throws it back up. It refreezes, gets a new layer of ice, falls again, gets pushed up again, over and over.
And every time that little ice pellet gets recycled inside the storm, it grows bigger. That's why hailstones have layers. If you cut a hailstone open, it looks like a jawbreaker candy, ring after ring of ice. It's so fascinating that nature builds hailstones like tiny frozen onions.
Here's a mind-blowing fact. A hailstone can travel up and down inside a storm 20 to 30 times before falling to the ground. That means it's being thrown around violently, freezing, melting slightly, refreezing, and building more layers.
And the crazy part is, the stronger the updraft, the bigger the hailstone becomes. To make a golf ball-sized hailstone, the updraft needs to reach about 60 miles per hour. For softball-sized hailstones, updraft must exceed 100 miles per hour. Imagine wind lifting ice balls that heavy. That's wild.
This brings us to one of my favorite facts. The largest hailstone ever recorded was found in South Dakota. It was nearly 8 inches wide. That's about the size of a small melon. Imagine something like that dropping from the sky.
I can't. That would literally punch a hole through a car. And speaking of damage, here's another unbelievable fact. Hail causes billions of dollars of damage every single year. Roofs, cars, crops, nothing is safe when a major hailstorm hits.
Absolutely. Now let's talk about something surprising. Hail doesn't need cold weather. In fact, hailstorms happen most often during warm seasons, spring and summer, because those seasons create strong thunderstorms with intense updrafts.
That's right. People imagine hail as a winter thing, but it's not. Warm, humid air near the ground helps build tall, powerful storm clouds. And high above those clouds, temperatures can be freezing. So you get warm air feeding the storm from below and freezing temperatures at the top. Perfect hail recipe.
Now here's something wild. Some hailstones are not perfectly round. We usually picture hail as little balls of ice, but in reality, hailstones can be jagged, spiky, or even shaped like discs. Sometimes they combine. 2 or 3 hailstones fuse together, creating weird, bumpy shapes.
Those fused ones are especially dangerous because they fall irregularly and hit harder. Oh, and here's another fun fact. Some hailstones are blue, green, or even pink. The color comes from tiny particles trapped inside, dust, algae, pollution, or even minerals from the atmosphere.
Nature really likes to customize things. Now let's talk about the speed of hail. Large hailstones can fall at speeds of 70 to 100 miles per hour. That's car speed. Imagine a baseball-sized chunk of ice falling at highway speed. No wonder hailstorms can shatter windshields.
It's terrifying but fascinating. And speaking of fascinating, I came across an unbelievable event. In 1888 in India, a massive hailstorm sadly killed over 200 people. It's one of the deadliest hail events in recorded history. It shows how powerful and dangerous hail can be.
Yes, and here's another bizarre story. In Argentina, there was a hailstorm that piled up so much hail that streets were buried 3 feet deep. It looked like a snowstorm, but it happened in warm weather. People had to shovel the ice like it was winter.
And here's one even stranger. There have been rare cases where small fish or frogs were found frozen inside hailstones. This happens because tornado-like winds can suck up lake water, including small animals. Then the storm freezes them in ice. It sounds unbelievable, but meteorologists have recorded such events.
Hailstorms can create lightning, thunder, strong winds, and even sudden drops in temperature. During intense storms, hail can suddenly appear without warning. One moment it's raining lightly, and the next moment, ice starts hammering the ground.
Another fact, there's an area in the United States known as Hail Alley. It includes parts of Colorado, Nebraska, and Wyoming. This region gets more hailstorms than anywhere else in North America. If you live there, your car probably hates you.
Seriously. Now, let's talk a little more about the science behind hailstone layers. When water freezes slowly, it forms clear ice. When it freezes quickly, it forms cloudy, white ice with tiny air bubbles. Because hail travels up and down through different temperatures in the storm, each layer freezes differently.
So by studying hailstones, scientists can understand how storms behave. The rings inside hailstones are like time capsules. They show how many times the hailstone rose and fell and how strong the storm was.
This helps meteorologists predict future storms better. Hail research is an important part of weather science, especially as climate patterns change.
Another cool thing, research radar systems can detect hail inside clouds by measuring how ice particles reflect radio waves. This helps warn people earlier so they can move cars indoors or take shelter.
Speaking of safety, during a hailstorm, the best thing you can do is stay indoors. Don't run outside to film it for social media. Shelter your pets, stay away from windows, and protect your car if possible.
Right, but of course we know people will still film it for clips. Humans are curious creatures.
Before we finish, a quick note about climate change. Scientists are studying whether hail frequency or intensity is changing in some regions because of a warming climate. Warmer air can hold more moisture, which fuels stronger storms. But the interaction is complex and depends on local conditions.
So meteorologists are watching trends closely. Improved radar, satellite data, and storm modeling give us better early warnings and help communities prepare.
Okay, let's end with a few rapid interesting facts about hail you can share at the next dinner party. First, some hailstones can be as large as softballs or even oranges. Second, hail forms most commonly in the late spring season in many parts of the world. Third, hailstones record a storm's history in their layers, just like tree rings.
And fourth, hail can appear in a rainbow of colors if atmospheric particles are involved. Fifth, hail causes billions of dollars in damage annually worldwide. Sixth, farmers often use hail insurance to protect crops. This is a big deal in agriculture.
We could talk about hail for hours, but our time is almost up. Thank you so much for joining us today.
If you enjoyed this episode, please like, subscribe, and share it with a friend who loves weird weather. Next week, we'll explore the secret life of clouds. Trust me, it's going to be amazing.
Stay curious, stay safe, and we'll see you next time. Bye, everyone.